My name is Ishan Godbole. I'm from Team Tech Titans, and today I'm going to explain the project predica Quake. So the premise of the product is that whenever earthquakes occur, there are many telltale signs. So the first thing I wanted to look at was the vibrations that occurred before an earthquake. There are two types that occur: P waves and S waves. These waves occur very quickly and very before the earthquake happens. P waves occur minutes to hours before an earthquake could happen, and S waves typically occur 7 to 14 days before an earthquake. So normal models right now detect the S waves and try to predict when earthquakes could happen. But as you know, when earthquakes happen, there are many telltale signs, from geochemical changes to tectonic plate stress, etc. I want to take all of these factors into account and make one solid product. So the factors that I'm taking account are mainly one, geochemical changes, which are the changes that occur in the water below the earth when the earthquakes are about to happen. Typically, the pH level of the water increases above the normal level, which is around 7.5. Now, because of this, earthquakes are more likely to happen, as this is a telltale sign. Other signs are such as radon gas radiation, P waves increasing at a certain frequency, S waves, etc. We also, using satellites, plan to measure the tectonic plate stress over a given area and the tectonic plate movement every year in millimeters. So using this, what we are going to do is we are going to train our AI model, which is very accurate currently, around 99.8% accurate. Using this model, we will try to predict the chances of an earthquake happening. What will happen is, in any given area, our product will be placed. Now what this does is, it uses the various sensors, vibration sensors, seismographs, etc. to measure on that given area. Then what it does is, using our communication system, which we plan to shift to satellite, we'll send the data to our server. On the server, AI model will be running. What will happen is, our AI model will run the data which was sent by the device and then send the response back to the device. Once the device will check the data and realize if the data is, for example, if the chances are more, then it will send a nationwide SMS, which will alert people in that area or further away as to the chances of an earthquake happening and whether it could happen or not. So this is the goal of the project. So this is the data set we've got, where we have the P wave frequency and the amplitude. Similarly for S wave and frequency for amplitude as well. We use tectonic plate movement per millimeter per year, then stress accumulation in megapascals, electromagnetic field, as that can also affect. The ionization levels is also a huge factor, as I told, radon emissions, groundwater, and groundwater ion concentration, and earthquake probability. Using all of these factors, we are going to be training our AI model. So as you can see over here, this is the AI model I have trained. We have used PyTorch as our framework, and we make a hidden size 65 as we're using our LSTM model. So the benefit of the LSTM model, it'll remember certain key factors in the dataset, as the whole major factor is memorizing as to what happens before an earthquake, as this factor is the goal of training the AI model. So we train the AI model, and as you can see, the MSE loss starts at 1, but then slowly goes down all the way to 0.0014. This is an incredible loss. Now this is in training, so we don't know if the model is overfitted, but as you can see in testing as well, the model has achieved a very similar loss, proving that the model is not overfitted but has generally got a very good score on the data, and is very well at understanding unseen data as well. So as you can see, these are our loss plots, and we have saved our model over here. As you can see over here, we have our 3 clients. So this is client number 1, client number 2, and client number 3. So the way this product works is, this will be the different microcontrollers placed in different areas around the world. And what will happen is, now for example, say client 1, what it will do is, it will collect data from our sensor 1 and sensor 2 or other sensors, and send it all the way over to our Pi. Our Pi is going to be the server which I've made today. So this server is a simple TCP server which can handle up to 5 clients. Currently, it will be upscale later on. So now what happens is, currently we have a pH sensor only, the reason, and our gas sensor. The reason we only have these 2 sensors is because other sensors we could not get immediately as they were out of stock. So what happens is, this is going to read the data from these sensors and then send it via a TCP connection over to our server. Then what our server is going to do is, it is going to run the AI model and handle the connections as well. So now I'll just show you the code for the Bharat Pi. So basically the way the code works is that we just use some basic TCP connection. We connect to our server's host port and IP address and to the internet. Then what we do is we activate our sensors, pins, etc. And I create basic functions for send packet and receive packet, where we just send this packet of value 1, value 2 to the server. And then we have the receive packet over here, which will just receive all the data, is the response. Now, the way the server works is that we basically just first load our model over here. And now currently we're loading our data set, which is over here. Then once we load our data set, we'll divide it into X and Y data. Then we get the pre-processing, we just pre-process our data and we make it into a tensor format, and then we put the model into evaluation mode. Now what we do is, we from our host, we set our host IP address and port. Now we have create our server TCP connection. Now what we do is we start listening on this port. Now once we start listening on the port, what we're going to do is we're going to make a connection with each of the IP addresses of all the Bharat Pis. So this is IP address number 1. See, now the connection has been established over here. Now we're just going to do the same over here. And then now it'll just require a simple restart on the Bharat Pis. And then the connection will be established, as you can see over here. And now we're going to establish our connection with client number 3. We're going to run that. Just restart our Pi. And now connection established with all 3 of the Pis connecting to each of their IP addresses. Now what we do is we are going to read the data. So when we read the data, first will come connection established, and we get the pH level data from our client. Now we can also read the data from the other clients as well. Now what we'll do is we'll get the output from our model over here. Then from all of those values, we'll get the mean value, which is around 56. After that, what we'll do is we'll send a response to our model. Now, whenever we send the response to our main Pi over here, now as you can see right now, basically what we have is the response code, which is going to send the response, which is the mean value over here. So we're just going to send our response. And now when we send our response, the model will receive whatever data is the mean value over here. So now as you can see, we'll just click response again, and then we'll once again get the data. So as this thing gets the data, I'm going to add the SMS system. Right now we couldn't buy the SMS module, but later on we're going to buy the SMS module, which will send SMS pings to all the numbers that the client has access to. And this is what the product is going to do. I hope you liked it, and I hope this product really changes the world. Thank you.